Earth, as we know it today, is full of life. From the tiniest bacteria to the largest whales, the planet is teeming with organisms. But billions of years ago, Earth looked nothing like this. The planet was a hostile, barren landscape. In fact, the very idea of life as we know it seemed impossible. In today's video, we're going to explore how life began on Earth. And it all started with some of the smallest, yet most important, organisms ever to exist: microorganisms. These tiny life forms may seem insignificant, but they were the pioneers that paved the way for every living thing you see today. So, what exactly were these microorganisms? How did they come into existence? And what role did they play in shaping the future of life on Earth? To answer that, we have to go back to a time when Earth was young, over 4 billion years ago. The planet was still forming, with molten rock covering much of the surface and volcanic eruptions constantly reshaping the landscape. The atmosphere was filled with gases like methane, ammonia, and hydrogen. There was no oxygen, at least not in the way we experience it today. Earth's oceans, where life would eventually begin, were just starting to form. Now, in this chaotic environment, something amazing happened. Scientists believe that within Earth's oceans, the first building blocks of life started to emerge. These weren't living organisms yet, but rather simple organic molecules that contained carbon, one of the essential elements of life. These molecules came together in complex ways, possibly sparked by lightning or the heat from undersea volcanic vents. Over time, they formed more intricate structures, eventually leading to the creation of the first primitive cells. Now you might be wondering, how did we go from these simple molecules to actual life? Well, it didn't happen overnight. In fact, it took millions of years, but eventually, under just the right conditions, the first life forms emerged. Tiny, single-celled organisms. We call these microorganisms, and they are believed to have appeared around 3.5 billion years ago, deep within Earth's oceans. These microorganisms were incredibly simple, but they were also groundbreaking. They were likely very similar to bacteria and archaea, single-celled organisms that could survive in Earth's early, harsh conditions. And while they may not seem like much compared to the complex organisms we see today, these microorganisms were the key to everything that came later. But here's where things get really interesting. One type of microorganism, cyanobacteria, completely transformed the course of Earth's history. Cyanobacteria were one of the first organisms to perform a process called photosynthesis. Photosynthesis is the ability to use sunlight to convert carbon dioxide and water into energy, producing oxygen as a byproduct. At the time, Earth's atmosphere was almost entirely devoid of oxygen. But as cyanobacteria began to multiply, they released oxygen into the oceans and the atmosphere. Over millions of years, this oxygen production built up, and we now refer to this period as the Great Oxygenation Event, which occurred around 2.4 billion years ago. This was a massive turning point for life on Earth. Before the Great Oxygenation Event, most life forms were anaerobic, meaning they didn't rely on oxygen. In fact, oxygen was toxic to many of them. But as oxygen levels in the atmosphere increased, the environment changed dramatically. Many anaerobic organisms couldn't survive in the new oxygen-rich conditions, leading to a mass extinction of early life. However, this new oxygenated atmosphere allowed for the evolution of more complex life forms that could thrive in these conditions, eventually leading to the development of multicellular organisms. Now, how do we know all of this? How can we be sure that these microorganisms were responsible for such a dramatic shift in Earth's environment? The answer lies in fossils, specifically fossils of stromatolites. Stromatolites are layered rock formations that were created by the activity of microorganisms, including cyanobacteria. These organisms would grow in layers, trapping sediment in their structures, eventually forming the layered rocks we see today. Stromatolites are some of the oldest fossils on Earth, dating back over 3 billion years, and they provide direct evidence of the presence of early life. What's truly fascinating is that stromatolites still exist today in certain parts of the world. You can actually visit living stromatolites in places like Shark Bay, Australia. These ancient rock formations are a living window into Earth's distant past, showing us how microorganisms shaped the planet billions of years ago. So, why is all of this important? Why should we care about microorganisms that lived billions of years ago? Well, without these microorganisms, especially cyanobacteria, life as we know it simply wouldn't exist. They were the first to create oxygen, which eventually led to the development of complex life forms. Every plant, animal, and human being can trace their origins back to these tiny, humble microorganisms that lived in Earth's oceans billions of years ago. They truly were the pioneers of life. And this is just the beginning of Earth's incredible evolutionary journey. In future videos, we'll explore the rise of more complex life forms, the mass extinctions that shaped the course of history, and the dramatic changes that Earth went through to become the planet we know today. Thanks for joining us on this journey through time. And if you enjoyed learning about the origins of life, be sure to subscribe for more deep dives into the history of Earth. Also, check out our quiz shorts to challenge yourself and test your knowledge on Earth's evolution. There's so much more to discover, and we can't wait to explore it with you. See you in the next video.